So I think we're supposed to get started in a few minutes, but of course that's just a rule and I ignore those. So I should start by saying, there's something very unique about this t-shirt, which is, what's unique about this t-shirt? No, it's not, that's not unique, it's black. What's unique about this t-shirt? I had to buy it. I just went through my closet a few months ago to sort of clean things out, and I'm down to my favorite 65 T-shirts. Everything else I gave away. But this is, I think, maybe the only one I bought. Because it's just too cool. It's too appropriate for a conference. Still a little bit early. So a little bit of this talk is because I was looking for something else to talk about. I've been doing microservices now for over a decade. I've been talking about it for at least over half of that time. And now books are getting published. We have amazing books out there. This is the third year of a conference about the subject. And frankly, it means it's time for me to move on to something else. So I have two new things I play with. One is Internet of Things. The other is virtual reality. So I'm playing with both of those right now. So to find a topic for this conference, it was like, this is kind of a natural idea. Let's take some of the Internet of Things I'm working on and talk about how I build these things with microservices. It also has a significant advantage in the US that I can now deduct all my Internet of Things toys. And I got to do something really quick to make sure I can deduct my virtual reality headsets as well. So this is a tax deduction. Thank you. So I want to talk about this. It's kind of sort of more of a fun topic. I don't think you necessarily pick up a lot of things that are probably brand new here. I always throw a slide up like this usually, but the key thing here is I'm an early player with technology. So whether it's LANs or network communications or GUIs or object-oriented programming or in this case microservices, I tend to be an early adopter of these things, trying these things out, seeing what they're good for. And it's kind of fun. It's fun to play in a sand pile that nobody's been playing with yet. So that's what I do a lot of. That means I'm kind of on the bleeding edge of things. So many years ago, I kind of was running the program for bringing LANs to the marketplace within IBM, and it seemed like every year after that was the year of the LAN in the trade press, and it kept going on for many years. But now we're to the point where, of course, everybody has LANs, everybody has Wi-Fi, all that stuff's pretty standard. So what's kind of, in my mind, the next big thing that I need to be playing with? And to me, I call this the age of agents. This is what's the big thing that's coming. This is a big thing that sort of ties a lot of things together. And I think Internet of Things plays into that. First of all, there's just a lot of that technology around. I mean, you see the big guys talking about agents. You certainly see all the products coming out there. And the interesting thing about these products, which I gleaned from a presentation by the Siri original founder, is it wasn't the voice recognition that was the really cool part, even though it seems like that's really cool. What the really thing was finding all these various services out there and gluing them together. The fact that here's a location for a restaurant, and here's Top Table, which can get you a reservation and put some money into place. And tying those services together was what was the innovation there. And so I think the real innovation is interacting in these backing services, making that work. And that includes whether it's the home or whether it's the industry or across industry platforms. All right, so what do I do in my house with this stuff? So this is kind of a demonstration of some of the technology in my flat. This is my flat. By the way, it's kind of colored. I kind of have colored it in various rainbow colors, so it starts in red and works its way through the yellows and the greens and the blues and the purples. I'm not that creative about that stuff. It's a rainbow. Whoa, come back. Back. Video should play. Click. Video should still play. Video doesn't want to play. Oh, here's some keys. Let's see if one of these does it. No. Oh, so disappointing. No little magic window comes up. Oh, anyway, shucks. What you'll see is as we pan across that, the lights at the top above the kitchen will change colors. And I can change them back and forth. And it's done with basically some of my fundamental toys. I have a lot of the Philips Hue stuff, so I have about 9 Philips Hue light bulbs with the hub there. I got about 10 meters of light strips, various wired places across my flat, below the entertainment center and below the vanities in the bathrooms, above the kitchen. And there's some really cool lamps. This is one of the cool lamps. It has 2 colors. You can have 2 different colors in your lamp and come down. So that's kind of been fun to play with that. I also have a couple of different hubs. I certainly have the Amazon Echo Hub. Really nice toy. Again, I'm very surprised in the industry. They put it out there, and all of a sudden it's been selling like crazy. And I have an Apple TV, which is kind of their idea of a hub. I also got some more toys. I got a Wemo, which is a programmable switch. It hooks directly to the Wi-Fi. It actually is a Wi-Fi hub itself. So actually you program it by hooking into this thing directly in its Wi-Fi port and then telling it what the other Wi-Fi should hook to is. So a lot of little electronics in just a socket right there. And the little guy at the bottom is one of those Amazon buttons that you kind of hit the button and it sends a signal to the Amazon AWS. I'm not sure where it goes yet, can't play with it yet. But that's all it does. Press the button, it sends a signal to AWS. So hopefully I can do something more interesting with that. But those are some of the toys I have to play with. I had this dialogue with a friend in California. He sort of said, dude, this Internet of Things in the house, I'm not sure what the proposition is. Why would anybody want to do this? And I'm like, because it's kind of cool, right? But, why would you want to do this? And he said, what's the business case? I mean, why would somebody bother doing this? And I said, well, there's less volume. If you get this thing into houses, the prices go down for all this gear and you get some standardization. I also think that the more you have it in the house, the easier it has to be to use. You can't sell this stuff into a house unless it's absolutely dirt easy to use. Not all of us are programmers. And of course, it's going to be fun. And then the more I thought about it, it was like, dude, this is a bit ingenuous of you to sort of challenge this idea. So I took out my phone, I got a little, port sniffers, whatever on it, and lo and behold, he has 74 devices hooked to his home network. And I'm like, whoa, you think internet is not, look, 74. And by the way, but he runs this off a 3-high wide rack in his basement. I don't have room for this in my flat. And I don't want to spend that much money on it. I think he has 190 wired connections into the back of this thing. And it's fiber running out to the other place. It's an incredible layout. But how can he say he doesn't think Internet of Things in the home is interesting when every light switch in this house goes through the center? So a bit ingenuous. So I want to be able to do it without a 3-high wide rack. I think that would be much more interesting. So there are a lot of guys in there sort of saying, I want to be your home center. And I think these companies realize that being the center of your house is going to be an important marketing advantage for them. And there are a lot of contenders out there. The Echo, I think, is getting a lot of publicity. It's got the ability to sort of wire some of your stuff in with some really straightforward APIs. Then, of course, you have the guys like the Google Home, which said, oh, this is a really good idea, then I need to duplicate it. And, of course, they do some things a little better and sometimes a little worse than the Amazon. But it's out there trying to be the hub for you as well. Again, I'm a little always concerned when Google is recording everything you say in the house, along with all the search results you're getting in my email and, goes on and on. The other guys in there is the Xbox. I mean, Microsoft says you have one of these in your house, we'll run your house with it. Now, they haven't really done a lot with that. It's really kind of hard to put code into this baby. But it's there, and it's sitting in my house with everything else, and you can certainly play with that. And of course, Apple's in there with the Apple TV. And frankly, HomeKit. HomeKit seems to be something that's very powerful for that family. Pretty easy to get your stuff wired into there. And almost all the devices can wire into HomeKit. So you can sort of pull your phone out or a tablet or even sitting here, make some changes to your system that way. The Philips guys sort of screwed it up. They were out there pretty early. They have a pretty good hub. And they updated the software, and they basically locked all the third-party software out of it. And immediately, of course, the industry gets really upset with you. You just locked me out. I can't put my own stuff on, hook my own stuff. And within a month or so, they changed it back. But it was too late. I mean, at this point, nobody trusts these guys to be the home hub. So they kind of were there and lost it because they got a little greedy about wanting to license all this stuff. One of the most interesting ones came out at CES last year, and I went to CES this year as well, and it was kind of out there a lot. And that is, the most interesting hub I ran across was the Samsung refrigerator. This is it. I mean, it's about a $4,000 refrigerator. It has this giant touch screen on the front of it. And you think about it, it's like, wow, actually really clever. Because what you can do with this gigantic touch screen is, first of all, it doesn't take any more space in your kitchen. It's still your refrigerator. And you have this gigantic touchscreen interface to the world that I don't get with my Apple TV, I don't get with Amazon voice boxes or Google boxes. This is a really, really good idea. So I'm not going to count these guys out because I think they got it nicely done. Now, I don't have $4,000 for a refrigerator, so I haven't got one of those yet. I think the price will come down. Again, hanging a screen on a refrigerator door, incredibly smart thing to do. Now, you got 6 guys in there competing for that, of course, and some others as well. So you get this really mess right now. And in fact, there's articles being written about what a big mess it is in the home trying to get around this stuff. This is one from just last month. It says we got an API economy chatter. It's like there's so many APIs, you can't get your head around them. You're going to hook to HomeKit, you're going to hit to Google, you're going to do Amazon. How about the Samsung refrigerator? I mean, all these guys want you to hook to theirs, and it's like, how do you choose? You certainly have spent a lot of money trying to hook to all these things. And so, of course, people are coming up with, well, we need another layer. Of course, there's always be a new layer, right? So here's a new layer. We're going to have 6 open source middleware projects already in place for Internet of Things. I guess we're maturing because now we got tools that don't do anything except sit between you and these other pieces of box. And I'm sure who's showing the cartoon? I think I saw the cartoon where he says, here's 14 standards, now we have 15. Oh, good, now we have 15 standards. And I think that's what happens when you get involved with middleware. So, what's my solution to this? I don't want to play those games. I don't want to play with their APIs. I don't want to try to write the code to hook in their APIs because they keep changing their mind. So, in fact, of course, the answer is let's write some microservices to sort of get around this stuff. So that's what I've been playing with. I've been a little further along, except I blew my motherboard out twice last month. And, of course, it takes a while to get a new motherboard and put it in there. So I'm a little behind in my implementation here. But one thing is, there's uncertainty here. I don't know what's going to happen. Anytime you have an uncertainty, I don't want to commit myself to build my own large monolith of code to run my household. I want to break this into really tiny pieces that I can swap out with a better tiny piece as soon as they change their API again. I want to isolate the change. And this is a principle we've seen over the years. I think it was actually in the Gang of 4 book. It talks about, you should have 2 classes. If things change at different rates, something's very steady, something changes all the time, separate those classes out. The same advice works for microservices. I expect, the interfaces to these little devices is going to change all the time. But I'm hoping my sort of core system of running the house will stay fairly stable because I don't want to change my mind about what I want to do. There's a lot of volatility, obviously, with evolving protocols. And so I want to kind of layer my functionality on top of base functionality and sort of build it up with a set of microservices. If you've seen my presentations before, you know I'm a big fan of asynchronous microservices, the rapids and rivers and ponds model. The idea of a rapids is it's an event bus. It has everything on it. If something interesting happens, you put it on the event bus. And there is only one. It's not a matter of which one do you put on. There's only one. You put everything there. And with everything being there, it makes it pretty easy to write a service that pulls things off. I do tend to use a 2-tier structure to try to keep the capacity of the rapids very high, so I tease out what I call a river. And once in a while, it's necessary to have a pond, this is the current state of the world. It's a static, stagnant body of water, but entities are important at some point, not just events. So I've used that model for quite a few years as my model behind that. So that's been driving some of my technology choices. So for my home interface and networking, I decided I'd use RabbitMQ. I am a big Kafka fan, but frankly, RabbitMQ is good enough for me, partly because I don't care about really old messages. The persistence nature of the Kafka bus is not interesting for me. So it's kind of good enough thing. I'll use Docker, of course. Probably use Swarm host to sort of distribute stuff because I don't need something really sophisticated. I do have colleagues that are Kubernetes wizards, and it's like I don't want to spend time becoming a Kubernetes wizard. So I'm going to sort of stay with Swarm. And frankly, I need to get myself some commodity boxes. These little cheap Linux boxes that run everything. I need to find a couple of those somewhere. They're pretty cheap. I can put one in the closet somewhere, hide it away, and run all my Dockers on it. So that's kind of what I'm going to do from a technology perspective. My architectural principles, and this is kind of a key thing. I believe in just-in-time design. I don't have an upfront design associated with stuff because I changed my mind too much. And when I used to write these things down, they turned out to be wrong. So the concept of just-in-time design is so you don't write things down that you're wrong about. You just don't write it down. You kind of figure it out as you go. And I also do architecture a bit on the fly. But unfortunately, it seems like architectural principles, the concept of how you want to do things and what you feel is important, those sort of things don't change that much. And so I want to kind of lock into some architectural principles. And the first one is I'm going to definitely do just-in-time design because I don't know what I need. And I'm probably going to change my mind as I see how it works or doesn't work. And that's actually happened several times. I'm kind of almost on version 3. And as I was drawing these charts, I came up with version 4, which I have to implement sometime. So I keep changing my mind about that stuff. I want to build behavior-oriented services. My services are not about entities. I don't want to have a service called my light service. I don't want to have a service called my lock service and my motion detector service. No, it's going to be sort of scattered about. Every service is going to do something interesting relative to behavior. Detect some situations and react to them, for example. So I certainly do that, behavior-oriented services. You publish conclusions. If you do something interesting, you should publish it back on the bus so somebody else may be interested in it. And again, that isolates each service from each other. But again, you do something interesting, get it out there. And finally, I'm going to get reliability through a couple of tricks. I mean, idempotency is very powerful. I mean, that comes in from a long time ago with services and protocols and the like. But the ability to bring 2 boxes up that tell the light to do exactly the same thing, but the light's okay with that, is very powerful. I get my redundancy, my sort of reliability. I can get that through just bringing multiple instances up. And I don't care if you send the message 5 times to the light to say, be green. If it works, it works. And as long as it doesn't flicker, I'm okay with that. So I'm going to use that sort of reliability through those sort of tricks. I'm also stealing some code from a workshop I run. I do a little microservices workshop. We ran one yesterday. And I have some code I've written around, especially around RabbitMQ and the like. So this is the Java version. Of course, I use Ruby when I do things, but the Java version, for those of you that don't understand Ruby, this is not very complicated. If you sort of look at line number, let's see if I can get the line numbers from here. So you basically set yourself up a little service. It listens to rivers, because that's where you attach your service to. So I define myself my static main. I basically define myself a connection to the rapids, and I'm going to use a RabbitMQ rapids. So I set that up. I'm going to require that that the packet should have these following values in it. So I set a river up. I set up a couple of values it's supposed to have. I also set up that these fields should exist. If these fields don't exist, I don't want to look at this message. So that's the filtering I do at the river level. And then I basically just register myself as one of the listeners for a river that has these traits. So if a message comes in, it meets all these characteristics, it will get passed to me. And the code it gets passed to is right here. So I invoke my packet method, passing in the connection, the packet that got received, and anything it doesn't like about the packet. If it's looked at the packet, finds some fields missing or doesn't missing, there's a whole little explanation of that. And basically, at this point, you kind of do whatever the packet tells you to do. Look at it, decide, make a decision, build yourself a JSON message, and send it out. A few lines of code. And by the way, if you don't like the packet, this packet doesn't meet the criteria, you get a chance to look at it and see why, which is kind of helpful for debugging. And generally, I just kind of turn off anything there because I don't care about the messages that meet that. And that's all it takes to sort of write a service. So I can just replicate this code, plug in another service, react to it. So it's quite easy to sort of build these little services up using this sort of simple framework. Oh, by the way, this is all open source code. It's out there on GitHub. If you go to GitHub, Fred George, the microservice workshop, you'll see this code for both C# and Java versions of this. The Ruby version is not quite up to the speed as this, but I'll fix that soon. But that code's available if you want to play with it as well. All right, so that's kind of the software I'm going to use, a little bit of the architectural principles. And what goes behind the covers here? So what does the architecture look like from a hardware perspective? Well, I got a lot of IoT hardware, obviously. IoT hardware tends to have 2 different interfaces to it. It always has some sort of low-level API that lets you sort of understand exactly what it's doing. And a lot of these boxes want to have more functionality because they want it to be your hub at some point. Something like the Hue Light controller has that. And it kind of has a higher level API that maybe manipulates something called scenes, which seems to be coordinating a bunch of things going on together. So the I/O hardware tends to have two different APIs that associate with that. Of course, I'm giving myself an event bus, RabbitMQ in this case. And then I'm going to define myself a set of what I call Tier 1 services. The job of a Tier 1 service is to interface to that hardware and put something on the bus about what the hell is going on. And it's responsible also for looking for a message on the bus that says, I want to change the hardware in some way, and it adapts to that. So you write little services that do that. Some services will be guys who are sensing what's on the hardware. Other services will change the hardware. So far, I've found that those are actually two different services. Yeah, you could glom them into one, but there's really no real commonality among them. So I tend to write those as separate services. So they're going to put it on the bus or either take from the bus reactions and how to handle that. The Tier 2 services are sort of the higher level things. This is the scene world. Scene seems to be the thing that most people are gravitating toward in home IoT as being sort of the concept of manipulating multiple devices in parallel. They call them scenes in most cases. So I have scenes in Tier 2. Tier 2, by and large, is pulling things off the bus and reacting to them. You see if something changes, some button got pressed or whatever. He might be invoking stuff directly into the hardware at a scene level. I'm trying to make sure I don't do that because I think that's kind of falling into the trap of becoming a proprietary interface, and I'll get myself tied into that, and that's quite volatile at this point. I do think that it may be more than one case where I want to react to something that does happen at that level. For example, this is the button that you can push in the little hub for Hue. The button's actually quite interesting because it has no wires and no battery, which I find pretty interesting. It turns out just the force it does to push a button, it takes a little force to push the button, generates enough electricity to make the signal work. So it really does it based on a force. You can take this out and carry it around in your hand and go click, click, click all you want to, and it's fine. So a pretty cool little thing. You have a 1 dot, 2 dot, 3 dot, 4 dot. This is, again, consumer electronics. So one of the things that happens when I push that dot, it goes to the Hue and says, Hue, by the way, I've just pushed the dot. What do you want to do? And the Hue says, I want to put a scene together. So I may want to be able to hook into there and know that a button got pushed and a scene got generated, and it's because a button got pressed. I may want to react to that in particular. Still playing with this to see if I can get around it. There's one more tier of services. I call those reactive services. These are the things that work with multiple things and coordinate it. Like based on a certain time of day, and in fact, I walk into a room, maybe you turn the lights on. If it's a different time of day and I walk into a room, don't bother with the lights. It's sunny outside. So that's sort of thing where you take a lot of these things and sort of make some decisions based on it. I call those Tier 3 services. There's also some sort of meta services that I need in there. Monitoring is a key one. One of the things you like to have is everything on the bus you need to be streaming out to a monitor, maybe streaming out to a database or at least some sort of file. So you see everything that went on. This is very, very helpful for debugging. So you have one of those to sort of give you an indication of what's going on behind the magic curtains. There's another tier of these I call error detection, detecting these aberrant conditions, things that you can sort of predict will go wrong. And if these things go wrong, please tell me. For instance, one of my services seems to be going down. It hasn't reacting. That's an error detection situation. He stopped heart beating. He stopped responding to polling messages. Then, raise your little hand, tell me I got something down, and let me know, and I need to go figure out how to fix that. And sort of the next step of that process is maybe you want to automatically fix these things. So if you're working in an environment where you have Swarm support within Docker, so one of the services seems to be down, go ahead and kill it and let Swarm kind of bring another instance up for me and take over from where it left off. So that's kind of the error detection stuff. So there's some kind of meta services in there. I've been playing a little bit with error correction, a little bit with monitoring. Haven't done any, error detection. Haven't done much error correction yet. All right, another video, which probably won't run. So it turns out one of the tricky things about this is maintaining the state of the device. And if I can get the video to run, maybe I have a right click on it. It has something. No. It runs interesting on my laptop. I guess when it's plugged into this device. Oh, that's kind of actually, so this is what I call an assistant service. So it turns out, here's all the lights. I got my green, my red, my blues. If I turn off the light switch, of course, all the lights go out around the kitchen. I turn it back on, they come back on white. It turns out the light bulbs, if they don't know better, when they come on the first time, they're going to be white because it's a light bulb. It's what it thinks it's supposed to be. The little Hue box, even though I told it I want them blue and green and yellow, he's not going to tell them again, even though he recognizes they're back. What I really want to do is, if I turn the light switch on, turn it back on, I want these same colors to come back. I want sort of I'm kind of call this an insistent state. I want you to be red. That's what I told you to be. The fact somebody walked over and turned the light switch on and off should not change your mind. You should still be blue and green when he turns you back on. So I want to build that sort of capability called insistent services. So here's how I'm building that. I call it the sticky colors. I call it choreography. This is a word. Where is he? Give you credit where credit's due. It was a word we used. Oh, there we go. Yes, your word. Choreography versus orchestration. Choreography, where these guys get together, but there's no necessarily somebody in charge of everything. It's kind of they work together. So we used to call these sequences and flows, but I think choreography captures it very nicely. So sticky colors. So I got me a bus. No surprise there. In this case, I got my Hue hardware, my little Hue controller, and I got this switch on the wall, the little guy with the 4 buttons on it. So I'll build myself a service called Hue State. And his job is he understands the state of the Hue box. That's his job. That's his only job. And he's going to do that by basically going to the hardware multiple times, probably polling it, periodically and say, what color do you think things should be? Or, what do you know about? What lights do you know about? I'll actually also keep track of lights he's forgotten about. Because if somebody turns off a light, then as far as he's concerned, it doesn't exist anymore. I want this little service to remember that it used to exist. Because one of the things I want to do is, once you poll this, I want to send everybody that says that, by the way, here's a device, here's its state, and if there's not, the device is sort of missing in some way, I'm going to send that message as well. And so one of the things I know, I'm going to say, hey, here's a device, used to be around, can't see it anymore, I'm going to publish that to the bus. My job is over. That's my whole world. I don't care about anything else. Not that hard to write. Not that hard to get it correct as well. Okay. I also want to be able to set these colors. That's a different service. I call this the be state. I want to be in a certain state. And so basically, given that information, he knows what color the light should be. I want you to be blue. So when he gets this message about, here's a device, and he's going to look at it says, oh, by the way, you should be blue, and right now you're white. So at that point, he will send, if necessary, tell you, go back to being blue. So I get sticky. He doesn't ignore the unknown messages because he can't do anything with an unknown bub. So he see the dev unknown message, he ignores that because he doesn't care about that event. Now again, if he says it should be red, he thinks it is red, he's not going to send a message. I don't want the bubbles to flicker. I don't want to say do those things. So that's why it's sort of an optional message based upon where the needs are. All right, so this gets me at a lower level, Tier 1 services. I have a concept of sticky. Now, how do I take advantage of that? Well, I got a service in Tier 2 I call my light scene. It's a scene, a set of lights associated with each other, and I create a scene. I think I probably have multiple scene services running for each scene I care about. Because frankly, you probably only have maybe 5 to 10 scenes in your entire house. So not a lot of services. They're cheap. I'll build them independently. So a light scene basically sort of figures out whether he's important or not. And so what will happen is somebody pushes that little button on the wall. And here I'm still wrestling with my best solution here. Basically, pushing the button means I want to have a certain scene show up. I'm going to be polling the Hue thing to make sure that somebody pushed the button, I need to know about that. I think I could get that working where he'll push that to me. But I may have to poll for it. So if necessary, I'll poll for that as well. So I'll poll for that information that says the scene is there. And having known that button's been pressed, I will say there's a request from a button got pressed, and I'll send that to the bus. The light scene stuff says, well, if somebody wants this scene to be shown, and he says, oh, I have a button request to do that, I will react to that. He may also react in the future to me pushing a button on my phone and sending something through HomeKit. Or it could be lots and lots of reasons something be on the bus saying, I want you to set a particular scene. This will be one of them. Given that information, he will basically say, for all the light bulbs I want to set colors on based upon that scene, he'll send a message to the bus saying, you should be this color. That'll get picked up by the set service, who will say, I want to be this color, and then he will turn around and forward that to the hue system, setting the colors with whatever the hue API is of the day. Again, isolating those layers. Sequence of actions there. Finally, here's one of my sort of monitoring services I probably put in place. It'd be nice to sort of have some way to sort of look very quickly and figure out what lights are on and what lights are off, what colors they are, etc. And I'm doing that with sort of a monitoring service. I'll call it a dashboard to sort of show me the lights capability. And basically, he's listening for these messages about what's known and unknown so he can build a status up. And he builds a status message in probably a JSON format saying, here's the state of all your lights and what everything looks like in your flat, and pushes that packet onto the bus. There'll be other people looking at that. For instance, when I get around to writing my iOS app that sucks that stuff up, I'll suck that message up, push it to iOS, and then I'll be able to build a user interface that says, here, there's what my flat looks like, or a web page that shows what it looks like. So that's just pushing that information out into a summary fashion. Again, with these sort of services and a few other services like a constant monitoring and lot, I have a fairly interesting system. Each of these services is very, very small, very easy to write, very easy to understand. But together, the choreography is quite impressive. It's a pretty interesting system. If all of a sudden Hue changes their API on me for some reason about polling things, I got one little piece of code, I'll change, and I'm up and running again. All the rest of my system is completely whole. This is a highly decoupled system. Again, when I don't know what I'm doing or where I want to go, very powerful for me to work with. Okay, so I'm going to go through some of the things I'm going to play with in the future, not necessarily in the right order, but I certainly want to integrate with some of these hubs so I can sort of control these things from outside. So I will be looking at either integrating with the Apple HomeKit, the Google Home stuff, or the Amazon Echo. I'll look at the APIs a little bit and probably pick one. I suspect it won't be the Apple iOS because I'm not really a Swift or Objective-C programmer. I'll probably wind up with the Echo at first if I get a chance. I also want to put some more devices in because there's some more things to play with. I certainly want to go, in fact, get a motion detector. This is the one from Hue, so it actually hooks into the Hue Hub. Obviously, there's standalone motion detectors as well. I think this one runs over 4 or 5 months on its little battery. So that's pretty good. I don't mind hanging that up and changing the battery that often. Of course, you have the Nest thermostats. So you put a thermostat in there, and it's nice when I'm traveling and forget to change my thermostat that I can sort of reach through remotely and get that done. Or certainly, motion detector plus time of day plus, thermostat or time of year. I should be able to sort of have that set automatically. And like I said, I need to go back and buy myself some sort of hub to run this on. I don't want to really run it on my gaming machine at home with this big power. I don't need that. I just need a little Linux box to do that. So that's one of the things I want to play with. The other thing is I want to look at the idea that how do you make this usable for the masses? I mean, I can do this because I can write code. That's not necessarily the general marketplace. I think we really need something that's equivalent to Excel for the home IT, where Excel became the tool by which we turned all those guys out there into programmers. So we didn't have to write that nonsense little stuff. We got out of that business by putting Excel in place. I think there's a pretty good candidate for sort of Excel for IoT, and it's pretty famous at this point. It's the old IFTTT, if this, then that. This is a kind of a language by which you describe reactions to certain situations, like time of day plus this should create this following situation. So it's quite nice. Unfortunately, it means it has to run on the web. You have to send your data to some server up there. Don't really want to send all the data from my house to some external place, not after all the hacks out there that exist. I kind of want to lock it down. But I think this is a great idea. I'm thinking about putting a service in place that every time a service comes up, it kind of registers itself with my IFTTT server that says, oh, by the way, here are the things I can react to. There's the things you can tell me to do. Here's the that's. And what about the, if this is? How about what sort of thises do you have? What sort of events do you exist? I want to be able to sort of catalog those. So I can sit there from a UI perspective and say, I have these events available to me. I have these actions available to me. How do I just glue these together in a very straightforward fashion? I think that'd be quite creative to do and kind of fun to get around and play some UI with that. But I think this is a very powerful necessity part for this stuff. And I do not want to have to run this in the cloud or send my data to an external source. I want to be able to do this in my house safely. I also have this, I have the concern, although I haven't run across it yet, of what I call ping pong, where basically the scenario is, one of my little scenes is saying, you should be blue. The other scene says, no, you should be red. And the guy says, well, he's turned blue on you. Oh, no, he should be blue again, and go back and forth and back and forth. Clearly, if I know about this case, I can probably code around it. But I'm thinking I could actually figure out a way to find these things through messages ping-ponging and actually put a service in place that monitors for this sort of situation and shuts it down in some way. I think, again, an interesting problem to try to figure out when I get to as well. Security. Of course, you know that several months ago, somebody hacked a lot of IoT devices and killed parts of the internet. I just saw an article just a few days ago that somebody went through and sort of probed into the U.S. to see how many open IoT devices there are, and it's in the millions. I mean, we're ripe for another attack like that instantly. So I want to make sure that to some degree, my little devices will not be part of those hacks. So I'm going to do a couple of things to sort of isolate it. First of all, obviously, there's going to be only a couple of services that are allowed to talk to the outside world. Otherwise, it's my world. You can't get to it. And that includes probably taking my RabbitMQ, and since I'm dropping it into a Docker container, there will be no even external IP associated with that available to the world. Only the services themselves that are using it internally. So you can't get to my bus and sort of steal stuff that way. I would probably actually set up my own little wireless hub and probably use MAC addressing for all my devices so that basically this non-public hub that doesn't talk to the outside world at all is completely isolated from the outside world. So the Wi-Fi you're hooking to is going to be a little private Wi-Fi that doesn't have access to these things. So these are some of the things I'm going to do just to lock it down. It's not that hard to do. Finally, one of the toys I want to play with that I'm kind of really looking forward to was kind of brought up with this, is that Docker runs on Raspberry Pi. And in fact, I think it was demonstrated the time before last at DockerCon. I think they were running 300 web servers under Docker on one Raspberry Pi. That sounds like a lot of fun. So here's here's a little cluster. Here's a cluster of Raspberry Pis. And it'd be kind of cool to get in there and just deploy my code to that little thing and hide it somewhere in the closet. And then I want to get my friend from California to come out, and I want to compare it to his 3-high rack. Said, look what I'm doing. I don't have 190 wires to my closet. I don't have a 3-high rack, and I can do everything you can do and more. So that's what I'm trying to get to. So that's kind of my venture into microservices. I'm getting a nice experience. Of course, I get more experience in microservices. You get a little smarter about these things. But some lessons I've learned so far. So this is what I'm intending to play with, and that's kind of the whole presentation. Thank you. So there's probably beer around as well as time for some questions. So off to you.
Right. Yeah. So are there any questions?
Hey, great talk, by the way. I have 2 questions. The first is, how can that ping pong situation happen if you only emit change events once?
I'm not sure, but I am concerned that if I have 5 or 6 light sources up there doing the light scenes, and they both get a signal from somebody that says I want to be a certain color, and the other one doesn't realize he should shut up, I think I may get a ping pong.
Okay, but it might only happen if not the last one wins, right?
Oh, no, but that's sort of the problem with insistent services. If you're insistent about what the state should be, they may in fact sort of say, oh, you're red now, you should be blue. And the other guy say, no, you should be red. And I don't know how fast they'll try to change, but it could get wicked.
Okay, and the second one was, I like that you use RabbitMQ because of the simplicity, and we do as well, but how do you manage retriggering initial state if you spin up a new component that basically requires information about the internal state of every other component?
I'm not sure I understood the question.
If you subscribe to events about changes in those components.
Oh, yeah, well, let's see. First of all, I set RabbitMQ up in PubSub mode. So basically, when a service comes up, it binds itself to RabbitMQ, starts listening for messages. The polling service that's doing the Hue state service is basically going in there, figuring out what the Hue has in it, and publishing a whole suite of messages onto the RabbitMQ, which everybody in PubSub is getting every one of those messages.
So imagine you spin up a new dashboard. Then it will only maybe take hours, days, weeks until it has the state of all the components connected, because they're not continuously publishing their state.
Oh, no, that's one of the things you saw with the little star beside the polling stuff. I'm polling every 5 seconds.
Okay.
I can't figure out how not to poll in that situation. But once every 5 seconds, I don't mind polling.
Okay. More questions?
Okay. Well, I'll keep you up to date about this stuff. Once I get this stuff kind of stable again, it'll be open source. So pull it down, bring it up in your house, get yourself some Raspberry Pis, and have some fun. Thank you.